Hey y'all, today you are going to learn about multiple representations of non-proportional relationships. So first, just like we did with our proportional relationships, we have four different representations: the verbal description, the equation, the table, and the graph. So in this case, we are given the verbal description. It says a taxi driver charges $3 per mile plus an additional $2 fee. So it's $3 per mile plus an additional fee of $2. So we are first going to write an equation. And remember, our equation is in the format of y equals mx plus b. So in this case, we are trying to find our y. Our slope, or our m, is going to be represented by the 3 per mile, we don't know how many miles, plus a $2 fee. So that would be the equation. Okay, next we're going to look at the table. So if this is our x, which is miles, our total cost is our y. So with 0 miles, we plug it into this formula, it would be 3 times 0 plus 2. So 3 times 0 is 0, plus 2 would give you a total cost of 2. With 1 mile, it would be 3 times 1 plus 2. So 3 times 1 is 3, plus 2 is 5. For 2 miles, 3 times 2 plus 2. So 3 times 2 is 6, plus 2 is $8. And when there are 3 miles, be 3 times 3 plus 2. So 3 times 3 is 9, plus 2 is 11. And lastly, 4 miles, 3 times 4 plus 2. 3 times 4 is 12, plus 2 is 14. Okay, now we're going to take that information and we're going to graph it. So our x is miles, and our y is total cost. Okay, so we have when x is 0, y is 2. So that point will go there. Next, when x is 1, y is 5. So there's 1, 1, 2, 1, 2, 3, 4, 5. When x is 2, y is 8. So 5, 6, 7, 8. And we can't fit the rest of that, but we would keep graphing it if we could. So there's the line right there. Okay, as you can see, unlike last week when we talked about proportional relationships, remember they had to be a straight line and go through the origin. This does not go through the origin, so we can tell that this is a non-proportional relationship. Okay, in the second example, we are going to use this table and fill in the verbal description, the equation, and the graph. So it says that the table shows a kite descending in the air in feet per seconds. So our verbal description we're going to use is a kite is at a height of 20 feet and descends 15 feet per second. Okay, we're going to take this information and we're going to write our equation. Remember, our equation is in the format of y equals mx plus b. So it says that the kite is at a height of 20 feet and descends, I'm sorry, that was not supposed to be 15, it's 1.5. Descends 1.5 feet per second. So y equals, if it's descending, that means it's going down. So it's going to be a negative 1.5 x, because it's per second, but it's already at 20 feet. So we're going to add that additional 20 feet in. Okay, we're going to take this information and we are going to graph it. So our X is going to be seconds, and that's our X, and our Y is feet. Okay, so I'm going to count by twos here. So 0, 2, 4, 6, 8, 10, 12, 14, 16, 18. We'll count by ones here. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So at 0 seconds, it was descended at 20 feet. 2 seconds, 17 feet. So that's going to be about there. Then 4 seconds, 14 feet. 6 seconds, 11 feet. And 8 seconds, 8 feet. So if we connect our dots, we have this line here. As you can see, it's not going through the origin, so it is a non-proportional. Also, if you notice the difference between these two graphs, this one is going up to the right, so that was a positive slope. Our slope in this case was 3. Our slope in this one is negative 1.5, so notice our line is going down. You are going to use these examples to help you fill in your assignment. Make sure you put it on your paper, turn it into Canvas, and then turn your paper in. Of course, while you're watching this video, if you need to pause or go back, please do that.